Hey gang, and welcome to week 4 of Code Club. In the past few weeks we've talked about a lot of the blocks that are available, but we said we were going to defer a couple till future weeks because they're a little more advanced. This is the week we're going to talk about some of those, including lists, clones, and broadcasting and receiving. Open up another browser window and log on to Scratch so that you can follow along. Have fun and let's start coding. The first thing I want to talk about this week is lists. Lists are an advanced type of variable. So if you go to the variables code blocks, you can see there's an option here for make a list. I've already got one created called grocery list, so we'll start working with that one. We learned a few weeks ago that a variable is a way to store data for your program. So for example, if you have a game, you could store the current score in a variable. Lists are just a special type of variable that can hold multiple pieces of data at the same time. And usually you want it to be related data. So for example, I have a grocery list, and everything I would want to buy at the grocery store I could add to my grocery list. An example you might use in a computer game could be the inventory that your character has. So if we use Minecraft as an example, you could have a pickaxe and you could have 25 dirt blocks and you could have 3 gold blocks. All that stuff would be stored in a list of these are the things that you currently have in your inventory. If you scroll down a little in the variables category, you can see all the different ways that you can manipulate the items in your list. You can add things, delete things, insert, replace. We will talk about all of these different ways of changing the items in your list. The first one, easiest to understand, is add thing to grocery list. And when this code runs, and I'll just click it to run it right now, it adds the thing to the grocery list. And if I were to put something else in here, it would add that to the list instead. So every time this code runs, it just adds a new thing onto the end of the list. And you note this has the rounded sides, so this could be a variable too. It doesn't just have to be something you type in, or it can be a number. It doesn't have to be text. I'm just using text in my example here. The delete block lets you delete one item out of the list, and it is based off of this number, which you notice every item in your list has a number next to it. And if you delete the item based on the number, so if I delete 2, it's going to delete something else. If I delete 1, it's going to delete things. So I'm going to add one other thing here just so you can see more easily what's going on. So I have 1 is thing, 2 is something else, 3 is other thing. I'm going to delete number 2, and it's going to delete something else. Now if I delete number 2, it's going to delete other thing. Now if I delete 2, there's nothing there, so nothing's going to happen. But if I delete 1, it's going to clear my list out. Delete all of list works exactly like you'd think it would. So let me add a bunch of stuff here. If I say delete all, it just empties out the entire list. I added a few things to the list just to make it easier to see what the insert and replace blocks do. The insert block will insert anything you want at an exact position into the list. So if I say insert thing 2A at position 2, what that's going to do is put thing 2A here and then move thing 2 down to position 3, thing 3 down to position 4, thing 4 down to position 5. I'll run it real quick and you can see it worked exactly how I said it would. The replace item block uses these numbers again to replace a specific item of the list with whatever you want. So right now it says item 1. Let's say I want to replace item 5 with thing 5 instead. So I put 5 and replace it with thing 5. Now when I run this, thing 5 is in position 5. The next set of blocks are the reporters and operators that let you see the current state of the list. The first reporter is item of list, and that gets the current value for any number in your list. So if I say get item 1, it's going to say thing 1. If I say get item 4, it's going to say thing 4. If I say something that's not in the list, like get item 8, then it's just not going to say anything because there's no 8 in my list. The next one is item number of a value in your list. So this looks inside your list and looks at all the values, and if the value exists, it reports the number that it's currently at. So right now it says item of thing. It's reporting 0 because there's nothing called thing in my list. If I change it to be thing 3, now it should report number 3 back because thing 3 is at number 3. Next we have a very simple one. It says get length of grocery list. This just reports how many items are in your list. So right now it says 5 because I have 1, 2, 3, 4, 5 items in my list. Next we have a Boolean operator called list contains. And what that does is it looks at all the values in your list, and if one of the values is the thing that you have on this side of the contains, it's going to return true. If what is in here is not in your list, it's going to return false. And you would use this in an if test like this. So I say if grocery list contains thing 1, then say thing 1 is in list. Well, thing 1 is in the list, so it says it. I have another example down here where I ask it to if thing 6 is contained in my list. When I run that, nothing happens because there's no thing 6. The last two blocks are show list and hide list, and they work just like show variable and hide variable that we talked about previously. They just tell whether your list is shown on the screen here. So if I hide list, it goes away. If I show list, it shows up on the screen. Usually when you have lots of variables and lists, you want them hidden typically, and you only show them for certain times, like, at the end of your game or something, you want somebody to see the high score, you would show that variable or show the list that's storing that data. I set up a simple program here that shows a popular usage of the length of block for a list, and that's to loop through your entire list and do something with every item in the list. Here I'm going to do something simple and just say each item in the list, but you could do more advanced things like if you wanted to add 5 to every number in your list or something like that. The way this code works is I have a variable called list counter that I set to 1, and that just tells my counter that I'm at the first item in the list. Then I do my repeat and I loop through the length of the grocery list. So it'll loop 5 times. Then every time I'm in there, I say the item at the current list counter variable value. So the first time through, it's going to be list counter value is 1. It's going to say thing 1. Then I change my list counter by 1, so that's going to increase it to 2 and loop back through the top. So now my list counter is 2, and it's going to say thing 2. And it keeps going through like that, where it says the current thing, increases the list counter, and then goes and says the next thing because the list counter got increased. Let's run it real quick and make sure that's what happens. Thing 3, thing 4, thing 5. And it works exactly like we expected. The next topic I want to talk about is clones. In Scratch, a clone is a way to create multiple copies of the same sprite that all have different properties such as positions, directions, costumes, and using if tests, they can even have different code. This is different than right-clicking on your sprite and saying duplicate, which creates an exact copy of your sprite. The difference is, when you create clones, it's all done through code, and that makes it much more powerful because every time you start your program, your clone can do something different while still having the same basic code in it as all of your other cloned sprites. There are a lot of different ways to use clones in your code. If you're making a card game, you could make the deck be the main sprite, and each person's hand be a clone of the deck. This makes keeping track of all the cards in the deck for your game simpler. If you had a game where you had multiple enemies that all look the same and have the same basic but different actions, you could use clones to keep track of all those enemies. Another reason might be something that has a lot of buttons in it. For example, if you're making an MP3 player, you have a stop button, a play button, a fast forward, reverse. You could have a main button sprite, and all of the individual actions like play and stop and fast forward are clones of that button sprite. The easiest way to show you how to use clones is to show you a working example. If you look at example 10, snowflake clones, that's a good example of how to use them. The main blocks that you use to create and control clones are in the control section. You got to scroll down a little bit, and you have when I start as a clone, create clone of myself, and delete this clone. This is the code for my snowflake sprite, which is what I'm going to use to create my clones of. And if you notice, I don't actually have a create clone in this portion of code. Instead, I have to switch to my backdrop code. And you see here, I have when the green flag is clicked to randomly pick a number between 8 and 20 and create that many clones of the snowflake. If I switch back to the code for my snowflake sprite, you can see that when the green flag is clicked here, nothing with cloning actually happens. All it does is hide the sprite. I scroll down a little bit and now you can see the code for the clone. And it says when I start as a clone. And what this does is it waits for an event for when Scratch tells it this sprite is starting up as a clone. So it waits for, back in our backdrop code, it waits for it to say create clone of snowflake, and then this code starts to run. And the way I'm using clones here is I'm using random numbers a lot. So point in the direction of a random number, set size to a random number, I go to a random X and Y position, I repeat for a random amount of time, I change my Y position by a random amount of time. All of this is done to make each clone looks like it's doing something differently. I'm going to run the code real quick so you can see what it does, and then we'll go and look through the code so you can see how it matches up with what each clone is doing. So it creates a bunch of different random snowflakes. They're all different sizes, and they're all kind of falling at slightly different speeds. That might be harder to see though. And every time I click it, it creates a different number with a bunch of different sizes. So it's not the same every time. And that's where all those random numbers come in. The code that makes up each clone starts out by pointing the clone in a random direction and setting it to a random size. Then it repeats while it's not touching another clone, trying to pick an X and Y position. So what happens here is it keeps repeating until this clone is not touching another clone. And whatever X and Y position it chose last is where that clone is going to wind up on the screen. Then it shows the clone, waits a second, and this is the code that makes it look like it's falling. So it repeats until the Y position is less than -175. And all it does then is changes Y by a random number between -10 and -20. So that kind of makes it look like it's falling slowly. And then it waits a random amount of time and loops back around and moves it down again. And waits another random amount of time, loops back around and moves it down again. Then when it's down to less than -175, it hides itself so it looks like it fell off the bottom of the screen. I'm going to add one more block of code to the bottom of this, and that's delete this clone. And what that does is it stops all the code that's running as part of this clone from running, and deletes this clone from the computer's memory. There's two reasons you want to delete your clones in Scratch. The first one is that each project can only have 300 clones total across all of your sprites. So if you don't start deleting clones and you're creating a lot of them, at some point you'll run across this limit and not be able to create anymore. The second is that it's just good practice to delete things that you don't need anymore. Like at the beginning of this, I had all of these snowflake sprites on the screen, and they would fall off the bottom and just hide themselves. But all this code was still sitting there. The graphics were still sitting there, all in the computer's memory. It's good to clean that kind of stuff up if you can. With the way the snowflake clone code works, I don't really have a way to track anything having to do with my clone. So if I need, to know what clone 25 of snowflake is doing, I don't have a way to do that. I'm going to switch over to example 11, and that's where we can see that we can use lists to keep track of information about our clones and use that information later in our program. As you can see, I have two lists here, one called clone X positions and the other called clone Y positions. And I'm going to use these lists to keep track of the X position and Y position of each clone that I create of ScratchCat. I also have a regular variable called clone number, and that's what I'm going to use to track each clone in the list. So remember, lists are ordered 1, 2, 3, 4, 5, however many things you have in the list. So the clone number for each clone is going to correspond with an item in the list. In this example, I'm creating the clones when the green flag is clicked in the ScratchCat sprite. I don't have any backdrop code to do it this time. The way this works to create the clones and the list that will keep track of the clones is, first I create a clone number of 0, and I delete everything out of the clone X and clone Y position lists. Then I repeat 5 times, which means I'll make 5 clones, and I'll add something blank to the clone X positions and clone Y positions. Then I'll change the clone number by 1, so each time through the loop it's going to add 1 to the clone number. So the first time through my clone number is going to be 1, the second time through it's going to be 2, the third time through it's going to be 3, etc. And then I'm going to create a clone. So again, the first time through, I'm going to create a clone with the number 1, and that's going to correspond to the position 1 in the clone X position and clone Y position lists. We'll scroll down to the when I start as a clone event and see that the first thing we do is read the clone number that was set up here right before it created a clone of itself. So the first time through the loop, the clone number is going to be 1. Then we have if tests that say if my clone ID is 1, go to this X and Y position. If my clone ID is 2, go to this other X and Y position. And there's that for each of these. 1, 2, 3, 4, 5. So this is kind of a fake example because I know there's only going to be 5 clones and I'm doing something specifically for each of those 5 items. But there are actual reasons you would do that. If we go back to the MP3 player button example, that could be a reason where you would do cloning like this. After we determine which clone number we're on and go to the proper X and Y position, that's when we update the list with the X and Y positions. So we replace the item at the current clone ID in the X position with the X position of this clone. And then we do the same thing with the Y position list. We at the clone ID in the Y position list, we replace it with the current Y position. Finally, we say the clone ID and show the sprite on the screen. I emptied out the two lists just so you can see that this actually works, and now I'm going to run it and you can see what happens. It creates all the clones. Here's clone 1, clone 2, clone 3, clone 4, clone 5. And then in each of the lists, it repopulated with the proper X and Y position, which we pulled out of here. So for clone 1, it went to minus 144.99. In the list replace, it replaced the current X position of number 1, which is minus 144. And in the Y list, it replaced the current Y position, which is 99. So this worked all exactly how we expected it to. Now what I'm not doing here is, after all the clones are created up here, is doing something with those lists. But you certainly could. You now know the X and Y position of every one of these clones. You could do something with that information up here. I'm just not doing it as part of this example. The next topic I want to talk about is broadcasting and receiving. Broadcasting and receiving is a way for your code to send a message to other code so that it can do something. So for example, you can have one sprite say jump, and any other sprites that are listening can jump if they hear that message. The broadcast and receive blocks are all in the events category. If you see, there's when I receive, broadcast, and then broadcast and wait. The broadcast blocks are how you send a message, and the when I receive block is how you listen for a message and then do something based on receiving it. I have a little demo set up here that plays music using broadcasting and receiving. And I have a bunch of sprites, a guitar, a piano, a drum, a saxophone, a button sprite, and a donut sprite. I'll just play this real quick so you can see what happens. Now when I click the green flag, nothing happens. I have to actually click the play music button for it to do something. Let's look at the code behind this, and first of all we'll look at the button sprite, which says play music on it. And all that this does is, it says when this sprite is clicked, so it waits for you to click on the sprite, and then it says broadcast play music. So this is going to send a message to anything else that's listening that says play music. If we look at the guitar sprite, we'll see that when the green flag is clicked, all it does is stop any sounds that might be running with the stop all sounds blocked. But when it receives the play music message, when I receive play music, it plays a C guitar sound, it waits 0.5 seconds, then it plays a D guitar sound and waits 0.5 seconds, and then plays an E guitar sound. The piano sprite looks almost exactly the same. It stops all sound when the green flag is clicked, and when it receives the play music message, it plays piano sounds. The drum sprite code looks a little bit different, and that's because in the drum, we also changed the costume when it runs. If you look when I play it again and click play music, the drum is moving a little bit. And that's because there's two when I receive play music blocks in here. And the first one changes the costume. It says next costume, wait, next costume, wait, next costume, wait. The other one actually plays the music. The saxophone block does something similar. It has two receive blocks, and one of them plays the sound and one of them changes the costume. And this is a perfectly valid thing to do. Usually when you do it, it's because you're having the two different blocks of code do very different things. So this one is a good example of that, because one of them just plays sound and the other one just changes the costume. You could potentially do this all in one block, but you don't have to. Finally, I want to look at the code for the donut, and you can see that there's no when I receive play music block here. And that's because donuts don't play music. It doesn't make any sense for a donut to listen for playing music. Now, if there was another message for when I receive taste delicious, maybe a donut would do something about that. But we don't have that as part of this. The last thing I wanted to show you with broadcasting and receiving is the difference between broadcast and wait. And the difference is that broadcast will send the message and then continue running any code underneath it right away. Broadcast and wait will send the message and then wait for any code in your receive to finish running before it moves on to its own code underneath it. This example is set up so that when ScratchCat receives a grow message, he changes the side by 200 and then waits 1 second. I have two ways of broadcasting the grow message in my program. The first is when the space key is pressed, it broadcasts grow and continues running the next code right away. When the up arrow is pressed, it broadcasts grow and waits for anything that received the message to finish before continuing on with the code. When we run this, if I hit the space key, ScratchCat will grow and say hello at the exact same time. If I hit the up arrow, ScratchCat will grow And because there's a wait of 1 second in here, he's not going to say hello right away. There'll be a little bit of a pause after he grows before he says hello. I'll run the code and we'll see what happens. So first I'll hit space. You can see that he grew and said hello at almost the exact same time. Now I'll hit the up arrow. He grows and then he says hello about a second later. So that's the difference between broadcast and wait. The last thing I want to show you this week are some fun ways you can change the look of your sprites or backdrops using what are called graphic effects. And those are in the looks category. You can see there's change the effect, there's set the effect, and there's clear graphic effects. I have 2 words of warning about the graphics effects. The first one is that it's a little bit difficult to predict what they're going to do, so I typically need to wind up playing with them a little bit to find out what the actual effect on my sprite or my backdrop is going to be. The other is that there's no way to tell what the current graphic effect on any sprite or backdrop is. So if you need to keep track of what your effect is so that you can back it out, you kind of need to use variables to set your effects rather than just typing numbers in. Just like with variables, we can either set the effect to a specific number or change it from its current number by an amount. So if I had set it to 0 and then I changed it by 25, the new color effect would be 25. Let's take a look at what the effects do. The color effect changes the color of your sprite, and it uses a formula to determine what the color effect is based on a number, and it's between 0 and 200, and if you go above 200 it kind of loops back around and starts back on itself like you had started at 0 again. So again, you kind of just need to play with it. So let's do 30. That makes him green. Let's do 60. That makes him a different shade of green. Let's do 100. That makes him blue. So you can see changing the graphic effect just changes the color based on some weird formula that I don't understand. So you just have to play with it a little bit. And then if I clear graphic effects, that sets him back to his normal color. The fisheye effect makes it look like your sprite had a picture taken of it with a fisheye camera lens. And then it's an ultra wide angle lens that makes it look like the inside of your picture is really blown up and the outsides are all kind of small. So if I set this to be an effect of 100, you can see the inside blows up a lot and the outside kind of looks the same, maybe got a little bit smaller. If I move this up, let's say to 200 and run it again, you can see it got even bigger and it starts to get this weird grayness in the middle because Scratch doesn't know what to do with it. So there becomes a limit where putting the fisheye, you can put any number in, but as you start putting higher or lower numbers in, it starts to lose its effectiveness of looking like a fisheye lens. And especially if you go negative numbers, eventually it just starts to look like this weird pixelated star instead of anything useful. I'll clear graphics effects again. The next effect is a whirl, and that just makes it look like somebody kind of took a washcloth and swirled it around on top of your sprite. So let me change this to 100. We'll see what that makes it look like. So you can see it kind of looks real distorted, but kind of circular motion. Let's move this up a little bit bigger. Let's say 500. And now it looks really, really swirly. And this is another one where you can set it as high or as low as you want, but the higher you go, the more useless it becomes as an effect. 1,000 is still looking good. 100,000, it starts to look like this pixely mess rather than a useful whirl effect. The Pixelated Effect is used to make your sprite or backdrop look like it's made out of a bunch of discrete blocks rather than nice straight lines. So let's set it to a pixel effect of 20 and run it, and you can see all the nice smooth lines have changed into these blocky pixel looking things. It looks kind of like an old-timey video game. This is one where the higher you do it, so let's change it up to 200, it just starts to look like big blocks of nothing, and the higher you go, the worse it starts to look, to the point where this is just one big white block. It's useless. So typically, again, you need to play with it to figure out what the limits are for the individual sprite that you're using. The Mosaic Effect basically creates copies of the graphic for your sprite over and over again within the current confines of your sprite. So let's set it to 10 to begin with. We'll see what happens. So it created 3 copies, so there's 4 little tiny scratch cats in here, and the higher you go, the more copies it tries to create within that original bounding box of how big your sprite is. So going to 100 creates a lot of them. I'm not going to try and count these, but there's a ton of them in there. And again, you start setting this too high and it becomes useless because you can't really tell what's going on. I set it to 1,000 and now it's just a bunch of random lines. The brightness effect controls how bright your sprite is, and what that means essentially is how much black there is in it. So if it's set to 0, that means it's however much is set in the original sprite. If you set it to negative numbers, that means more black is going to be part of it. So if I set it to be negative 50, that's going to make it less bright. If I set it to be 50, that's going to be more bright. And the way it works is if you get to be around a negative 100, that's going to be basically all black and you're not going to see anything else. And if you set it to be 100, that's going to be all white and you're not going to see anything else. The last effect is the ghost effect, and that shows how transparent your sprite is. And if it's a high transparency, that means you're going to be able to see through it. And if it's a low transparency, it means you're not going to be able to see through it. I'm going to add another sprite to this real quick. Put it right underneath Scratch Cat, and then we'll start changing the ghost effect to see what happens. If I set it to 0, that's essentially the normal transparency level. And the higher I go, that makes it more transparent and more see-through. So 10, you can start seeing a little tiny bit of the X through there. 50 should make them about half transparent, so you see way more. And then if it's 100, that's completely transparent. So 100 is completely transparent and he's all the way see-through. The last thing I wanted to say about the graphics effects is that they're cumulative. So for example, if I change my color effect by 25, that turns him green. And then I set my fisheye effect to 100, and that blows his face up like that. And then I set my pixelate effect to 10, and that makes him pixely. And then I change my ghost effect to 50, and that makes him transparent. All of these things all happen at the same time. So you can set multiple graphic effects. And then if you want to clear them, you have to clear them all at the same time using clear graphic effects, unless you would set up variables to record how high you set them, and then you could set them back using those variables to be their original values. Alright, that's it for week 4. I hope you enjoyed it. Go out and do some coding on your own. Have fun, and we'll see you next week.